Hello everyone. In this video lesson, you will learn how to solve absolute value inequalities. So notice that in this lesson, we're just going to focus on greater than, okay, the inequality that is greater than, and then we'll do less than or equal to on the next video lesson. So the steps on how to solve absolute value inequalities for greater than are the following. So it's going to be same as solving absolute value equations with one difference. And that is that on the left, okay, the left side inequality, or the left hand one, you're going to turn the inequality, okay, and make it negative. So I'll explain what this means as I go over the next three examples. So I'm going to turn the inequality. So since this is the absolute value is isolated, you still got to follow those steps. So you got to isolate the absolute value. Once it's isolated, then you start solving. Okay, so I'm going to break this open, meaning I have 2x plus 4. Now notice, I'm going to do the left hand one. So this is the left hand one. I'm going to change the inequality. Okay, so I'm going to turn it, instead of greater than, it's going to be less than. So then make it negative. So that's negative 6. The other inequality is 2x plus 4 is greater than 6. Okay, and then solve. So subtract 4. So we have 2x is less than negative 10, then divide by 2. So then x is less than negative 5. Okay, that's 1. The other, I'm going to subtract 4 again. So then we have that 2x is greater than 6 minus 4 is 2, and then divide by 2. So then the inequality is x is greater than 1. So then what I'm going to do is, let's say this is negative 5, okay? And then we have, let's say this is positive 1. So notice that we do not have equal to, so we know the circles are going to be open. So what this is saying is that from negative 5, the graph goes to the left. So all the values to the left of negative 5, not including negative 5. And this one, from 1, all the values greater than 1, so to the right of 1, not including 1. So that's the graph that goes with this inequality problem. Okay. All right, second example. For this one, I need to isolate the absolute value. There's a plus 4. I'm going to subtract that 4 first. So then we have 2 times the absolute value of w minus 2 is greater than or equal to 6. Then we want the absolute value isolated. There's 2 in front of it. Let's divide by that 2. So then we have the absolute value of w minus 2 is greater than or equal to 3, which is 6 divided by 2. Once the absolute value is isolated, then we set up the 2 inequalities. So we have w minus 2. The left one is going to turn the inequality symbol. So this is less than negative 3. Or the other, okay, the other is w minus 2 is greater than positive 3, and then solve. So let's add 2. So then w is less than negative 1, and for this one, also add 2. So w is greater than positive 5. So we have the inequality. Solution for this problem is w is less than less than, and I forgot the equal to, right? So let me go back and correct that. Just add it. So equal to, because that matters. So that means you're including negative 1 and positive 5. So then, let's see, we need negative 1. So let's say this is negative 1. And let's say this is positive 5. So from negative 1, we have a closed circle. So that means we're including negative 1. So all the values including negative 1 to negative infinity. And also from 5, this is saying greater than or equal to 5. So that includes 5. So from 5 to the right, okay, of 5. So that means we can't use any values in between negative 1 and 5. So this is the solution to this problem, and this is the graph that goes with it. Okay, one last example. For this one, I need to isolate the absolute value. So that means I'm going to multiply by 2. So I'm going to multiply this side by 2 because I have a 1/2. 2 times 1/2 is 1, which gives me just the absolute value of 2x minus 1 is greater than positive 8. Okay, from there, the absolute value is isolated. So let's break the absolute value open and set up the 2 inequalities. So this is the left hand one, so 2x minus 1. is less than negative 8, and the other is 2x minus 1 is greater than positive 8, and then solve. Okay, so I'm gonna add 1. So we have 2x is less than negative 7, then divide by 2. So then x is less than negative 7 halves, or you can also say 3.5. Okay, so negative 7 over 2. I'll leave it as a fraction for now. And then also add 1 here. So then we have that 2x is greater than 9, then divide by 2. So x is greater than 9 halves, or 4.5. Okay, so let's say this is negative 7 halves. And let's say this is positive 9 halves. Okay, so this is saying less than, so that means from here, not including negative 7 halves, we can go to the left, which because all those values can be used by this problem, by this inequality. And then greater than 9 halves, so that means not including 9 halves. So then from here, all the values to the right of 9 halves. And this is the graph that goes with this solution to this inequality. I hope this is not too challenging or too difficult. But if you have any questions, don't forget you can always ask those questions in the classroom. Okay, thank you for watching. See you soon. Bye-bye.